Good morning. I have my special guest star, Little Stinks, who's going to help me with the introduction of this video. Little Stinks, aka Feliz Navidad, aka Baby Trash Mouth. I'm going to let her go because she doesn't like to be held too long. Thursday, you need to sit. Alright, so good morning. I hope everyone's doing okay out there. And this is going to be for my Integrated 1 class. This is for Unit 7, Lesson 20. And we're going to now look at the types of angles that we've been dealing with, but what happens to those angles with the lines are parallel. So I'm going to try and go through this very quick. I don't want to make it more difficult than it needs to be. Let's go ahead and go through our 3 goals. Our first goal is going to be to understand what parallel lines do to corresponding angles. Okay. Our second goal is going to be to use vertical angles and linear pairs to fill out the other values in this picture. And the last goal is we're going to make claims about the other types of angles. The other types of angles are alternate interior angles, alternate exterior angles, and same side interior angles. So let me very quickly highlight for you just a pair of corresponding angles. Remember, corresponding angles are angles that are in the same position, right? And there's this idea in mathematics that we call a postulate, or a why don't you have a seat, Thursday? Have a seat. Sit down. Come on, sit. Just sit. There you go. There's this idea in math that we have called a postulate or an axiom, and what that means is it's something that we accept as true. And the axiom that I'm going to talk about is called the parallel line axiom. And what it means is if you have parallel lines, the corresponding angles, the angles that are in the same position, for this example I have the angles in the top right, the angles that are in the same position, they have to be the same. They have to be congruent. They have to open up to the same amount. Okay? So parallel lines make equal corresponding angles. Okay, so that's going to be our starting point. So I'm going to go ahead and erase this real quick, and instead of putting the arcs that show that those angles open up the same, what I'm going to do is I'm going to put the measurement. I'm going to make up a measurement. I'm going to make up a measurement that's very easy to work with in this lesson. So what I'm going to do is I'm going to tell you that this angle is 60 degrees. And since I know the lines are parallel, and parallel lines make equal corresponding angles, that means that the angle in the same position down here, that must also be 60 degrees. Okay? So I'm going to check off my first goal. Alright, you good there, Thursday? I don't want to step on her. She's right in the way. But she's being a good dog. Alright, our second goal is we're going to use vertical angles and linear pairs to fill in the other angle values. Now remember, vertical angles look like this. They're angles on the opposite side of an intersecting lines, like an X, right? And we know that they're equal. We actually made that argument before we went on quarantine. And the other type of angles are linear pairs. And linear pairs are angles that when you add them together, they open up enough to make a straight line. So I want to first go through this picture and I want to look at the vertical angles to what I have. Alright, so remember, this is the pattern of vertical angles, and I have that right here. Okay? Now, let me point something out very quickly. So parallel lines make corresponding angles equal. But these angles are what we call alternate interior angles. And so it appears that parallel lines make equal alternate interior angles. The vertical angle to this angle is down here. And that's also 60 degrees because remember, vertical angles are equal. Okay? Alright, so I think we've done as much as we can for now with vertical angles. Let's move on to linear pairs. Remember, linear pairs, the two angles make a straight line. So if I cover this up, I have a straight line, which means that 60 degrees and something else must add up to 180 degrees, because that's what a straight angle adds up to. And if we take 60 degrees away from 120 degrees, we see very quickly that this must be 120 degrees. Right. So it works here, those add up to 180 degrees, as well as it works here, these add up to 180 degrees. I could use vertical angles and say that this is 120, or I could use the idea of linear pair, and this would be 120 degrees. Right. We saw in the previous, when we found this angle using the vertical, the alternate interior angles, and just making what we would call a conjecture, maybe this should also be 120 degrees. And in fact, if we use the idea again of a linear pair, the two angles added together make a straight line, and if I have 60 of it, that means that I have 120 right here. And again, notice the angles in the same position, the corresponding angles are equal, and that happens because the lines are parallel. And I also want to point out that alternate interior angles appear to be equal. And again, using the idea of vertical angles, this would be 120 degrees. Okay? So I used vertical angles and linear pairs to fill out the other values. So I'm going to check that goal off. Alright, so my last goal is to make claims about the other angles. And, you know, I'm missing a very important piece of vocabulary. All of these claims only happen when the lines are parallel. Okay, so we have to really understand that parallel lines do something to all of these. Alright, so let's look at alternate interior angles. These are alternate interior angles and they're both 60 degrees. These are alternate interior angles and they're both 60 degrees. So parallel lines make equal alternate interior angles. Alternate exterior angles, like this 120 degrees. Oh, this is also 120 degrees. These are alternate exterior. And these alternate exterior angles are both 60 degrees. And so just like alternate interior angles, parallel lines make them equal. Same side interior angles. So this 120 and this 60 and this 120 and this 60, they will always add up to what we call, they always add up to 180 degrees. We call that supplementary. So when the lines are parallel, same side interior angles, those add to 180 degrees. And the last type of angles corresponding, remember, angles in the same position, top right are 60 degrees, bottom right are 120 degrees, bottom left and bottom left are 60 degrees, and top left and top left are 120 degrees. So parallel lines make the corresponding angles, they make them equal. This only happens when the lines are parallel. Okay, so these are the claims that we're going to make. We can actually argue this through a logical argument that these results must happen. And I may or may not put another video. I have to see how I'm doing with regards to time in this. But again, I just wanted to kind of give you an idea of what would be happening in this situation. So again, we start with parallel lines, and we get all this. So let me erase this. I really want to reinforce this last piece of information. I don't want to step on you, Thursday. So all of these are true when we start with parallel lines. Okay. Starting with parallel lines makes all of this happen. That's the lesson. The homework is pretty simple. You're going to be given a picture, and you're going to be told that the lines are parallel, and you have to figure out what type of angle you have, and or angles you have, and it'll tell you the measurement of one of the angles, and from there, you just tell me what the unknown value has to be. So if they're alternate interior, alternate exterior, or corresponding, the other angle has to be equal. If the angles are same side interior, then you have to figure out what other number you need so that the two numbers add up to 180 degrees. That's literally all that this lesson's about. So have a good day, everybody. I will post the next video next week. Let's say goodbye to Thursday. Bye, Thursday.